Using intercepts. The x-intercept is the point at which the graph crosses the x-axis, while the y-intercept is the point at which the graph crosses the y-axis. We can use the x and y intercepts to graph a straight line, provided that we know the coordinates of these points. To find the x-intercept of an equation, we substitute y equals 0 into the equation and then solve the equation for x. To find the y-intercept, we substitute x equals 0 into the equation and then solve for y. So when we looked at graphing using the slope-intercept form, so y equals mx plus b, we use the slope and the y-intercept to sketch a straight line. When we are using the equation in standard form, then we want to use the x and y intercepts to graph the line. That's easier than trying to find the slope or rearranging the formula into slope-intercept form. So you'll notice that in these examples, they're not quite in the ax plus by plus c equals 0 form, but we're still going to use these versions of the formula or the equation of the straight line to find out the x and y intercepts. So the first thing you want to do is you want to substitute 0 in for y. And then solve for x. So we are going to put x plus 5 times 0 equals 5. And then 5 times 0 is 0, so we're just left with x equals 5. So now we know that the x-intercept, so if we were to write this as a coordinate, would be 5, 0. So if this is the x-axis right here, I know it's not as thick as we would like, but we're going to use this. And then the y-axis is this vertical line right there. We're going to go along and we're going to assume that our units are in ones. So we're going to go along to 1, 2, 3, 4, 5, and that's our x-intercept right there for number 1. Now we're going to use the same equation and we're going to substitute 0 in for x and we're going to find our y-intercept. So we're going to do 0 plus 5y equals 5. The 0 doesn't add anything, so we're just left with 5y is equal to 5. Now, because we have a coefficient in front of our y, we want to divide both sides by 5 so that it cancels out on the left-hand side. So we're left with y equals 1 because 5 divided by 5 is 1. And if we were to write the y-intercept as a coordinate, it would look like 0, 1. So then we could go ahead and plot our y-intercept right there. And then we could connect these dots using a straight line. Ideally, if you're using this on paper, you'd be using a ruler or some sort of straight edge to help you. I'm just going to quickly sketch this here, so it might not be perfectly straight, but you get the idea. We're going to add arrows on either side of this line to show that it continues forever. And you know what, I'm just going to do this one over again. All right, let's try that again. So sketching my line, drawing my arrows, there we go. And I'm going to label this as number 1. So that's a quick and easy way to help us sketch a line when the equation is not in y equals mx plus b form by finding our x-intercepts and our y-intercepts. So let's go through a couple more examples. For the equation 2, we have 2x minus 7y equals 14. So same process, we're going to substitute 0 in for the y to find our x-intercept, and then we're going to do it again where we substitute our 0 in for our x to find our y-intercept. So we're going to have 2x minus 7 times 0 is equal to 14. So 7 times 0 is 0, so we're left with 2x is equal to 14. Now we need to divide both sides by 2 to get rid of the coefficient in front of the x. So 2 divided by 2 is 1, so we're left with x, and 14 divided by 2 is 7. So if I was to write this as a coordinate, it would look like 7, 0. So now I can go ahead and plot my y-intercept of 7. So 1, 2, 3, 4, 5, 6, 7. I'm going to move this over here. There we go. So now I can plot that. My y-intercept at 7 is right there. And now I'm going to find my y-intercept. So I have 2 times 0, take away 7y is equal to 14. 2 times 0 is 0, so we're left with 7y equals 14. And now we're going to divide both sides by -7. -7 divided by -7 is 1, so we're left with y. And 14 divided by -7 is -2. So the coordinate of our y-intercept would be 0, -2. So I'm going to plot that point right there. And now I can draw or connect my lines. Show arrows on either side to show that the line continues forever. And I'm going to label this one as line 2. Let's go through 2 more examples. So we're going to use this grid right here. This is our y-axis, the vertical, and our horizontal is the x-axis. My apologies for this technical difficulties. All right, here we go. So I'm going to find my x-intercept first by substituting in the 0 for my y. So I have 3x, 5 times 0 is 0. So 3x is equal to 15. I'm going to divide both sides by the coefficient in front of the x. So divide both sides by 3. 3 divided by 3 is 1, so we're left with x. And 15 divided by 3 is 5. The coordinate of our x-intercept would be 5, 0. So I'm going to go ahead and plot that point right there. And then we're going to do the same thing, except we're going to substitute 0 in for your x. So 3 times 0 plus 5y is equal to 15. 3 times 0 is 0, so we're left with 5y is equal to 15. Divide both sides by the coefficient in front of the y. 5 divided by 5 is 1, so we're left with y. And 15 divided by 5 is 3. The coordinate of our y-intercept is 0, 3. So we can go ahead and plot that point right there. And we're going to connect these dots using a straight line, drawing arrows to show that it continues forever in both directions. And I'm going to label this as 3. So our last example is in the true standard form of the equation. So we have 2x minus 6y minus 12 equals 0. So you'll notice we have to do one extra step in these equations to find our x and y intercepts. So we're still going to start by substituting in zeros for x's and y's. So we're going to substitute in the 0 for y first to solve for our x-intercept. So we have 2x minus 6 times 0 minus 12 is equal to 0. So we have 2x minus 6 times 0 is 0. Subtract 12 is equal to 0. So at this step, what we want to do is we want to add 12 to both sides to get rid of the constant on the left-hand side. And doing so will eliminate the constant from the left-hand side, but it will add that constant to the right-hand side. So now it becomes an equation like we're going to have up in examples 1 to 3. So we have 2x, and negative 12 plus 12 is 0, and then 0 plus 12 is 12. So now it becomes an equation like we had up there, which we can solve. So we're going to divide both sides by the coefficient in front of the x. So 2 divided by 2 is 1, so we're left with x, and 12 divided by 2 is 6. And the coordinate would be 6, 0. So now I can go ahead and plot my x-intercept of 6, 0, so right there. And now we're going to find our y-intercept. So we're going to substitute 0 in for the x and solve for y. So 2 times 0 is 0, so that is eliminated. So we have negative 6y, take away 12 is equal to 0. So same thing, we're going to add 12 to both sides to get rid of the constant on the left-hand side. So I have negative 6y, negative 12 plus 12 is 0, so it's gone, and then 0 plus 12 is 12. So now I want to divide both sides by the coefficient in front of the y, so we're dividing both sides by negative 6. Negative 6 divided by negative 6 is 1, so we're left with y, and 12 divided by negative 6 is negative 2, which means our coordinate for our y-intercept is 0, negative 2. So we're going to go ahead and plot that point right there, and then we're going to connect these two dots using a straight line, arrows on both sides to show that it continues forever in both directions, and we're going to label this as line 4. So that's a quick way to sketch graphs when we have our equation in standard form or a version that is not y equals mx plus b by finding our x and y intercepts, plotting those 2 points, and then connecting those dots.